Okay, so today we're going to cover 11.3 day 1, which is area of sectors. In order to do that, we do need to recap a little bit from last chapter and refresh our minds on the area of a circle. Okay, so remember the area of a circle is pi r squared. So again, the only thing you need to find out is what r is. Once you have that, you are good to go. So our first example, the area of a circle, the diameter of 6. Remember the diameter is going all the way across through the middle. So we want half this, so r would be 3. So the area of this circle would be pi times 3 squared, which is 9 pi, and then whatever units we're working with, u squared. If we're given a circle whose radius of a circle, as we do not know, but we know that the area is 20, so same formula, but in this case we know what a is. So we know 20 equals pi r squared. Okay, so we got to get r by itself, so we divide the pi over. So r squared equals 20 divided by pi. And then we take the square root of both sides. Now, I'm not going to make you have to worry about simplifying that, but if you go to your calculator, this is going to be about 2.5 units. Okay, just remember pi is a number, 3.14 if you approximate it, or you can use the button on your calculator. And the last one, find the diameter of a circle whose area is 81 pi. So again, 81 pi is your area. Okay, diameter is not in our formula, so what we want to do is find r first. So pi r squared divided by pi. We get r squared equals 81. Take the square root of both sides. R is 9. So your diameter would be double that, so your diameter would be 18 units. And so that's just a recap a little bit of last chapter. But moving into today, we're talking about sectors of a circle. Okay, a sector just represents a portion of the circle. And the best way for you to think about a sector is to think about a piece of pizza. A lot of you guys probably have had plenty of that over this little break here. Okay, so if I were to draw a sector in here, okay, this would be a sector. Okay, oops, make that one a little bit better there. Okay, your sectors always meet there at the center. Okay, and what we'd be talking about is the area that is inside here, that actual piece of pizza that you would be cutting out. Now, normally you would have letters at those points, so we'll call this A, B, and C. So I can name this sector A, B, C, or I could call it sector CBA. You'll notice that in the center is the center of your circle. Sometimes you can also do this little image, draw in a little sector, A, B, C, if you'd like to do that as well. So again, a sector is just a piece of the pizza. Alright, so over here on the right, we have a circle whose radius is 4. And they're telling us that this arc here is 70 degrees, which would also mean that C is 70 degrees there. So the first thing to say is find the area of the circle. Okay, so going back to what we've already worked with, pi r squared, pi times 4 squared, that's 16 pi, units squared. Then they want to know the area of the semicircle. Okay, well, Semicircle would be half that circle. So what would I do with my answer? I'm just going to divide that in half. So a semicircle would be 8 pi units squared. Or if I do a quarter, that means I'm breaking into 4 equal pieces, so I would divide it by 4. So 4 pi units squared. So those are some of our common ones, but we can do this for any size sector. Okay, in order to find the area of any sector, you're going to use this next formula here. The area of a sector is equal to the measurement degree. So what's that central angle, or the degrees of that arc, or the arc, divided by 360, which would be a full circle, times the area of the circle. So really what this part over here on the left is doing is it's figuring out what percent of the circle we want. Okay, so in this example, if our circle is, we have an arc there 70 degrees, it's 70 over 360. We already found the area was 16 pi. So we multiply those two together and we reduce. Okay, so if I multiply that in my calculator, leaving the pi out, because we want to leave this as exact, so you're going to have your pi out front. If I do 70 times 16 divided by 360, that reduces to 28 over 9. And again, this is area, so it's units squared. So we're going to do a couple practice problems down here below using what we just talked about. Okay, so in these examples, we're going to use that same formula each time. So the first one, they give me 12 as my radius. So to find the area of this circle, it'd be pi times 12 squared, or 144 pi. So again, that's your area of your circle. And I want to figure out what percent of the circle it is. Well, it's 65 degrees out of the 360. So we're going to do 65 divided by 360 times 144. Okay. And that comes out to 26 pi. And again, units squared. One thing to remember is your sector should always be smaller than whatever you find your area of the circle to be. So once I found my area to be this 144, I should know that my sector should be smaller than that. Okay, our second one here, a bigger sector than the last time. So again, area of the circle is pi times r squared, so it's 4 in this case. So we get 16 pi. Well, we have 135 degrees for the central angle. So what portion of 360 is that? Times our 16 pi. And you'll find that that reduces to 6 pi units squared. Okay, so now on these bottom two, we're going to look to try to find the shaded region. Okay, we're trying to find the area for those shaded regions. So first of all, find your big circle. So radius is 6 here, pi times 6 squared. Area of the circle is 36 pi. Now, with this being a right angle, that means we got 90 degrees here, which means we'd have 270 left, or you can remember that would be 3/4 of this left. So 3/4 times 36 pi reduces to 27 pi units squared. And we got one more problem here. Okay. We want to do a little bit of writing on the circle here to help us out first. Okay, find our radius is 10. So we can go pi r squared for the big circle. So 100 pi. Now remember, going back to vertical angles, if this is 75, this is also 75. So in total, our shaded area is 150 degrees of this. So 150 over 360 times 100 pi. And when you go to solve this, remember, just multiply 150 times 100 and divide by 360, and you can simplify that into a fraction. Do not multiply by pi. We want to keep it exact. So 125 pi over 3 is what this reduces to, and that's